The purpose of this video is to take you through a unit I've made for my IB Higher and Standard Level Physics course. It's on the IB syllabus's Option G, Electromagnetic Waves. When I start off a unit, I often start by giving the students something they might find interesting, like this electromagnetic spectrum song from YouTube, goes through a lot of the characteristics. And there's also these applets from PhET. Most of them are just for review, but this one over here is about making lasers, and that'll come in one of the activities we do. The idea of making this unit in particular is for me to investigate whether or not ideas like those of John Biggs about constructive alignment, going from intended learning outcome to teaching and learning activity to assessment, have practical value when the intended learning outcomes are largely provided by the syllabus itself, and the assessment is also mandated by external bodies, in this case the IB. So I've made an Excel spreadsheet to help myself out in planning, and in column B here you'll see the IB assessment statements. For physics, those play the role of intended learning outcomes. So you can see them listed here. There's quite a few. Now, so I wrote those out, or copied and pasted them in, and then in column F here you can see the participant activities. The hidden columns are just for alignment with the IB syllabus in other ways. I'm focusing on the teaching and learning activities here. So see, the first one I want to do is a rich picture poster. It's going to get posted to a forum, and then it has some peers looking at each other's work and trying to build a discussion. That'll be described more in the activities. And you can go down, I've made an activity for different sets of these assessment statements. There's far too many assessment statements for it to be practical to have one activity per assessment statement. You just wouldn't finish the course, and it wouldn't make any sense anyway, because they're very tightly related. So instead I take a group of them that seem to go together quite well and have a larger activity that encompasses the group. Also in this document you can see the technology that will be used, the resources, the facilitator's role, and how assessment and feedback will be given. So I went through and I filled all these out to begin with, so I could get my planning in order. So I'll just go back to the Moodle itself, and you can see that document is here under unit planning for my reference. The students wouldn't see that. And then afterward I have my different sections of the unit. So there's G1, G2, G3 and 4 together, and G5 and 6 together. G5 and 6, see it says HL, that's for higher level, and the others are for both standard and higher level students. Now if I go into some of these, the first one is just an article on the speed of light. That's more of an interest thing to get the unit started off. The first activity is this one, electromagnetic waves and dispersion forum. If I go into that, then you see there are some instructions about creating a rich picture. This particular rich picture is one that I made for an earlier topic in the course, so the students are familiar with it, and it shows them some things about what maybe a rich picture could look like. It could include things constructed by drawing tools, some text, some labels, some images with the copyright acknowledged, and so on. Their rich picture is going to end up being somewhat different because it's on the current material, not the unit back where that one was made. So their rich picture has to accomplish these 4 tasks. And you'll see later that these are assessment statements from the IB, which fill the role of intended learning outcomes. It mentions the tools students can use. They can use pretty much anything that will work for a rich picture, but these are some suggestions. The resources, where they can find the content to build a rich picture from. And then it tells them about how to post in the forum. So their first forum post is going to be their rich picture itself. I can show you in a second that there's some of this in progress because we've started this activity in class, but we're just getting underway in the unit, so other activities aren't started yet. And continuing post is where the discussion starts to build from looking at each other's rich pictures, and that's the stage we're at now. So we have some continuing posts going on, but not for all discussions. And then later there'll be final posts where there's a little bit of reflection going on and a comment of how well the rich picture and discussion fulfilled the IB assessment statements, so tying into those intended learning outcomes from this perspective. Students can give each other ratings to see how well it did, 2 points per outcome. The IB in physics often does this 0, 1, 2 scoring, so it's something that students are familiar with. So they give 2 if it's been completely addressed, 1 if it's been partially addressed, and 0 if not at all, and then 2 for each for a total of 8. Okay. The assessment from me is on participation, so they get a mark of 6 for their first post, 6 more points for their second, 10 for their third, and 10 for each additional one after that. And depending on how many they do, their mark can get higher. So you take the number of them that they've done. So if they've only done 2 posts, they'd have 12 points, but that would average to 6. If they'd done 4 posts, that'd be 32 points, so it would average to 8, so they'd have an 8 out of 10. If they did more posts after that, then it continues to bring their average up a little bit. I see that I don't see the discussion topics there, so I'll refresh my page. So you can see here that we've begun to make some discussions. So some students have managed to put up a rich picture they constructed in class, but they don't have any replies yet to their picture. Others starting to get some replies. So if I go back to my topic list, we'll spend less time going through some of the others because that gives you the idea. For the next one, EM wave transmissions, absorption, and scattering form. In this one, it goes right into what you're going to do for the first post. So it tells the students some questions that they're to address, and then you have a continuing post and final posts similar to before. In the next one, you have a let there be laser light form, because it's about lasers rather than just regular visible light. In this one, they start off by making screencasts. So similar to the one about making the rich pictures, they have to make a product to begin their forum. So here they're making screencasts about the fed applet that I showed you earlier. I just showed you the picture of it earlier. So the applet's a little bit involved. So I made my own screencast here, that's what this is, and posted it on YouTube. And it takes the students through how they can use the applet. It doesn't do the actual task for them, it just shows them how to use the applet. And then we have description down here. This is the applet itself, they can click that to run it. And then what they're going to do inside of it, they have to accomplish. So again, these things they have to accomplish are the IB assessment statements. So there's my constructive alignment. How do they make their forum first post, their continuing post, and their final post, and what they can do afterwards. We have the ratings and the assessment idea once again. So moving on to G2, we see we have some forums here which are similar ideas. We'll go into all the details of those. The optical problem bank is a bit of a different idea. Here it is here. So what they do in the problem bank is that they have to use digital means to solve a related problem. The problems are mainly coming from their textbook in these cases. The textbook aligns to the examinations they have to take at the end of the course. So it's good for them to do those textbook questions as well. So if we look down here, we have a group-based wiki, and the students are just named by numbers, student 1, 2, 3, and 4. So within a group, we'll decide who's which of these 4 students, and then they will have their wiki page here to put their solutions under. There's another wiki for a problem bank. So depending on the topic or subtopic, some things are more likely to be helpful than others. So here we have discussion forums, and here we have some wikis with a little bit of forum discussion about them. We have a derivation forum. Down here is an interesting forum, proposal to cite a light fringe pattern. In that one, I make use of an online tool called Vuvox. So students are going to make a proposal, just like it says, about citing a light fringe pattern, and in that proposal they have to accomplish these 3 items. Here's some description on how to make the proposal, and here's the whole task as a Vuvox itself. So I made this one for the students so that they know about what they're going to get themselves into, telling them how to make their proposal and things they should put inside their proposal. And then once they're finished, they get an embed code themselves from Vuvox, and they put it into their forum. So they embed it in the forum, and then once it's into the forum, then it becomes a discussion tool. And you see down here the guidance for first post, continuing post, final post, and assessment. Keep the trend the same so that students know what to expect while making the tasks different enough to be related, to be good for the specific assessment statements and intended learning outcomes. Here you also see a couple of files. These are for experiments that we'll do hands-on in the laboratory. So there's no related Moodle work for that. It's an experiment, and they'll have a traditional lab write-up, which is a mandatory thing for the IB. Here we have another problem bank, and then we get into the higher level material. I'm going to give the higher level students more freedom to decide when they get to the higher level material how they're going to address some of the assessment statements. So I have some things in here. You can see this thing about Bragg's Law, a topic in physics, with X-rays and thin films. I'm giving them a guided activity here, but there's more to these topics than what I'm showing here. And they're going to put that in these EM Waves HL wiki. It's for the higher level students. And in that wiki, they're going to get to decide how they're going to address some of those assessment statements. They might decide to do a VUVOX, they might decide to do a rich picture, or they might decide to do something more traditional. It's going to be up to them. Down here, I brought in a link for theory of knowledge, which is a big thing in the IB. You're supposed to try to link your subject to it as best you can. So we have a forum here about the concept of a wave. It has some guidance to start off with, and then students take it from there. And finally, we integrate some Google Forms in here, where the students can go through the assessment statements and see how well they believe they've addressed them, or how well they believe they can do on them. Can they actually explain or describe or outline the way that the assessment statements are asking them to about the particular content? A little bit of self-assessment there. And that's this unit in a nutshell. So this video is taking you through the planning document that I've used, as well as the activities that are in the unit. All these activities are fully formed and ready to go. We're just starting the unit ourselves, and we're still on this one, EM Waves and Dispersion Forum. I hope to be able to report back that it's been a resounding success.